All right, it's been a little bit, but we have an interesting one here. There was a lot of conversation yesterday about this Axios NPM stuff, and early this morning I saw this post by Colson, and we have a macOS backdoor called WaveShaper, attributed to DPRK. Colson does a great job as usual, going through a lot of this and how it ends up going to these actual Mako, this com.apple.act.mond. Looks like it's inside of the library caches directory. And yeah, so thought it was a good opportunity to take a look at an interesting or potentially interesting Mako. Haven't spent a lot of time on this, but yeah, just want to mention also Patrick added this to the malware collection for Objective-C if you want to go and grab that. It's here, WaveShaper, 4 hours ago. And yeah, so the sample that I see being referenced in a lot of these blog posts is this one. And what I did was I just grabbed the ARM64 slice of this, which if you go to like relations, you'll see the ARM64 slice, which ends up being this 445 hash. And that is what I have here. Okay, so let's start from the top and kind of walk through this. Again, haven't really spent time on this sample, so should be fun. Okay, so we're in the main function. There's a lot of stuff that I don't want to look at, like these, I don't even know what this is, this class, this low man, not sure how to even say that. Looks like this is JSON related stuff. So I guess we may need to look at that at some point, but let's just see the first time there's an interesting function call here. And we have this generate UID. I'm assuming this is going to generate some kind of unique identifier for the host. Let's just open this up in case it's missing anything. So we have two arguments being passed to this generate UID. And let's go in here. Yeah, so this is gonna just get a random value. And I assume it would write this to this pointer that was passed into arg1. And that's what it probably will do. Let's see, arg1, x0 moved into x20, x20 moved in here, x23, storing this value that's returned into x23 inside of a loop. Okay, yeah, so going back, so let's generate UID and here, and let me get this in main. It's going to return this, and this should be the length of whatever that UID is. I'm just going to put that in here. So UID. Okay, next thing we have is getOS, which getOS is passed in this value, this pointer via x8 that it does see here. So let's see if anything else was passed. x8 and nope, because x0 and x1 are overwritten with values. And it's going to go do a sysctl by name. And it's going to look for this hardware optional .arm64 value. It's going to return that. It's going to return this. And it looks like it's also looking for Mac ARM Max64. So it's going to check to see what chip architecture this is running on. So getOS is an interesting way of doing that. Let me make sure I'm not missing anything. Okay, so it's going to return that, and it's going to return that into the value that was passed into arg1. Okay, so Mac ARM. Okay, so I'm going to return that into this value. So chip. Okay, init dir info, another function. Let's see what else was passed into this. So just this right here. Okay, init dir. So first thing, I'm gonna skip over this vector stuff for now, just JSON stuff, and get home dir. I'm assuming this is just gonna get the home directory for the user. Get env, yep, and it's gonna iterate based on that offset, and it's gonna grab that value, and that's gonna return here. It looks like these are like handlers to return a string. So it's going to return that into arg1. So this is going to be the user home dir. User home dir. Okay. And from there, what else? There's a lot of stuff in here. And I don't want to look at all this. So let's just kind of scroll init dir info. Let's see if it does anything else. Okay. So we have, what is this value? /. Let's just make that a string. /. And then we're passing in whatever this is for applications, user home dir. It looks like we are, is this like appending? Let's see. Grab that, basic string. These are long. Okay, let's go back. Applications, user home dir, library application support. And let's see if there's anything else. Does a file system status looking for those. And then we have this get detailed file list. Okay, so let's see what else. Iterator, so we can iterate through a directory. And let's see if we can find, oh my goodness, there's a lot of these. Stat, see if it exists. So many of these JSON related calls. Probably returns all this in like JSON. And let's see if I can find anything in here that looked more interesting. Get detailed file list. So it looks like this is going to iterate through whatever is passed in, and it's going to grab these. Oh, look, we have a name here for that. Isdir is passed in here. Size bytes. Okay, so it's just categorizing. Oh wow, it's getting a lot of information for these directories. Okay, that's cool. So let's go back out. Get detailed file list is here and is passing. We pass this value as that first required path. Okay. So continuing from there, let's see if there's anything else that kind of pops up here. Nope. Okay, so bunch of directory querying in order to get information about the directories for application, and it looks like this user home library and then application support. Okay, so that's what's going to return there. Just categorizing everything. It looks like then all of these functions that I don't want to look at then happen. And let's see what else is interesting here. If we just kind of, well, there's a dumb function. Probably writes all this into a big JSON blob. And we have a interesting sounding function here called report. And it passes in 3 values to see if that's right. Yeah, so we have x0, x2, x1 that are passed into this report function. Okay, with an if statement here, if arg1 is not 0 and arg2 is not 0, and then that value is not 0, that value is not 0, then we continue. If not, we just return. So this is expecting values to be passed into these 3 arguments. Well, I'm not sure how arg3 gets used. Okay, looks like this is an array, I assume, because we're dereferencing this array and then adding a 0 to it. That's interesting. Okay, so getting that value, and then we are going to encode something. So something was passed in here. Let's see if we can find where that was passed here. And this value gets written to here. Let's see if this is from before. Okay, so does this return? This gets 2 values. Nope. Okay, so we are encoding a value. Oh, this also gets an x8 value here, which is this, which probably returns from there. Yeah, loading that into Q0 and then storing this here. So whatever was encoded, so this is an example of this function actually receiving more than just 1 value. We have 3 arguments, it looks like, and we can check this here. Yeah, so we can see that 3 arguments were passed to this function. So we actually have to go back and rewrite this so that we can see this cleaner. So let's do a Y. Oh, this is gonna be ugly, but we're gonna do our best. Let's just say that they're pointers, arg2, and then int 64 t arg3. And I'm just gonna remove all of this extra stuff because it gets difficult to see. So all that type information, I don't want that. And boom. Oh, actually, it was in, this is wrong. It was arg3 at x8. That is going to be the 3rd argument. So that'll be x0, x1, x8. Okay, that looks like it makes more sense here. These 3 values are passed in. This is returned based on this value. Okay, x5, boom. Okay, so something is encoded at some point. This is returned, but I believe this one is the one we're most interested in, this value for this 3rd one that's encoded, which is here, because then we're gonna use that into this, we're gonna pass this onto the stack. Okay, so let's continue. So this is potentially interesting. Passed to stack. Just so I can remember what it looks like. Okay, so now we're gonna use curl, which I believe the Code Insights does mention this. Libcurl, yep. Okay, so curl easy init. So curl handle, and that's going to be passed to all of these setup functions, which these are kind of missing values. We have all these setup curl. We might have to do something different. So that should be able to find that, but I should have had that in here, but it looks like it's not there anymore. Okay, so we're gonna have to make this make sense. So there's different values that are passed into these curl functions. So we have x0, w1, and then some of these are going to receive a value via the stack. And the way that you can see that, if you look closely, is we have SP being referenced, and we're moving something onto that address with a store instruction. So these are going to have more arguments. And the one that we're most interested in is going to be this 2712, because I believe that's going to be the actual URL. So the URL is passed in via x21. And where was that from? X0 here, x21, x0. So just to remember, we're going back to report, back here. X0 was x19, so let's follow x19 up to see where this was set. Oh, okay, so this was actually, the URL was passed in as an arg. So we have argv here, argv, array of arguments, and we actually moved this to, let me see if I can find it again, here. That's an x1, right? So we have x0, x1. We're adding 8, the offset of 8, which is going to be the argv1. So that tells me that the URL is actually a launch argument. Oh, let me make sure this is doing this. So we're gonna edit this, and that's going to be URL launch arg, which makes sense so that you don't, as a malware author, you're not actually writing, like hard coding the URL into this binary, and you can use it differently. So without relying on that specific infrastructure. So that makes sense because in the report function, we have this URL here. It's an X0, it's moved into X21 here. And then in X21, if we can find it again, X21, we're storing that on the stack and calling this, which is going to be for the URL setup. So I'm just gonna put URL, and these are wrong. These are missing a lot of values here. So if we change this, I'm just gonna make them int64 t arg1 int64 t arg2 for now. Okay, so that makes more sense. It's a little bit more clear to see. And this has a callback function, which you can see referenced here. It was passed via the stack for the write callback. And I assume that once it makes that connection, it is then going to append that return value to a string. Okay. So it's probably how it gets commands back from the C2. Okay. So we don't have the C2 here, but we can see like the user agent string, which looks like it was mentioned to be some kind of Windows XP era user agent. I don't remember what those look like, but maybe that's what this looks like. Not sure. Okay, so we have this. This communicates out with the C2 that was passed in via launch arg to this binary. And we have this write callback, which is appending that result, which this is wrong too. It's not showing the actual R1 int 64t, R2 int 64t, R3. Okay, and then, yeah, so then we return that result from this write callback, and that gets returned. So that appended string that was returned by this communication with the C2 is then returned by report. Okay, so let's go back. Report is going to return here. So this is going to be return appended string, looks like. Not sure how that gets used later. Let's see if we can actually find, oh my God, there's so many of these functions. Oh, it looks like you may have a reference to it, but I think it changed FP, which might not be what we want. Okay. Oh, do work is an interesting function with the actual URL, and it's an offset of this function, this pointer, so I'm not sure. But all right, let's go up and then let's see what else we can learn. So we have, oh, before that, get OS version. I thought we did this already. Didn't this already get called up here? No, get OS. Okay, so get OS version. And now this is going to run another sysctl for the current OS product version. And it's going to return that value with the sysctl by name function. Okay, so product version. So that should get returned. Oh, let's go back to main and let's go back here. This should be returned into this pointer. So this is going to be OS version. Oh no, this is going to mess up all of these. They're only, there are a few, these are right next to each other, and oh man. All right, I'm going to change that because I don't want to mess this all up. Okay, so OS version here. And then get time zone, which we can already assume what that does. Time as printf with UTC to get that timestamp right. Okay, So time, OS install time. What does it use? VarDB, Apple setup done. So it gets a stat of that and it checks like the creation time of that. That's cool. I think that was mentioned actually. Yeah, here. Okay. So that's how that does. The install time. Boot time, I'm guessing boot arg, it does like the boot. Let me see if I can see it. Nope. Oh, there's a lot of strings here. Let's see, sysctl, yeah. So it probably just gets that boot time, get current time, okay, cool. And then going back, oh, this messed me up again. Model, what model does is hardware model. So a bunch of sysctl by name and sysctl calls to get information from the host. So not the lazier approach. This is actually using C APIs to do it instead of like one of these command line arguments or one of these command line tools. Okay, so a little bit more sneaky. So CPU brand string. So get CPU type, but I feel like that already happened up there, but okay. Then it grabs all that and then it does a while true. So there's a huge function here. It does all this stuff with all those functions that we don't want to look at right now. And another report happens and then do work happens. And I think do work was referenced here. Persistent loop polling the C2 for JSON formatted task. It features capabilities to base 64 decode remote payloads, writes them to temp, and signs them. Okay, cool. All right, and let's go back before all this. So a huge loop. This is probably a loop that's referenced there. This huge while true loop. And we have format time, get host name. Okay, so we're just getting the host name here. I mean, symbols are pretty straightforward. Yep, just getting the user, returning the user to this function, formatting the time, getting the process list. Oh, so this is actually shelling out. So it's doing a p open, so you can look for this command for detections potentially. ps-eo user pid. So it actually does have a p open for a new process. Go back and probably just puts all this into a JSON. And let's look for another interesting function from here. So does a bunch of stuff, querying the endpoint, bunch of JSON related API calls here, which we don't want to look at. And let's see, going all the way down, I know there was another report call at some point, report, passing in that, and we already looked at this function. So it does another call within this loop. And looks like for whatever is returned from this, if it is equal to 0, we continue. So this return value is used here. And let's see if our return thing, and then let's see, arg. So it would be this one. And we have that. We're then passing in this value into the do work. Okay, so let's see what that is. Copy this, these values, and then do work. Okay, so what does this do? Let's look through it. Type, kill. Those look like potential commands. PE inject. This is not a PE file, so that's interesting. Type kill, yeah. Checks against that. What is this? Bin, IJT bin. Not sure what that is. Inject binary? Probably. Okay, so maybe there's components from the Windows side of this in here. Because PE inject, yeah. potentially. Man, there's so many of these. I don't want to look at these. Okay, continuing. Run script. Oh, run script. So if it's returned with this run script, then let's see what that will end up doing if we can actually find it. Do action dir here, run dir, required paths, do action dir. Where is the call to while true? Man, I don't want to look at these. Get file detail list. Okay, so let's see where the actual call to. So continuing, if it is, we continue here, and we should see at some point the call to, oh, we can see much more strings on this side. Status, type run dir, command result, command ID. Okay, bunch of JSON stuff. And let's find, there's another report here. And type command result. Looking for, I guess the call to OSA script is in here somewhere. So we might just have to keep looking. Do work, because I can't find the actual function related to that. And same report goes back. So this is all related to JSON stuff. And let's see if I can actually find OSA script somewhere. Does it actually see something? Yeah. Oh, so it was a function called do action scpt. This is inside of, where was this called? This is inside of do work, but it was hard to see. Okay, cool. So this is where the actual Apple script stuff happens. So base 64 decode to string. So arg1 is the command, it looks like script command maybe. And then it's going to be decoded, probably decoded to this argument that's passed in. Yeah, so this is going to decoded, oh man, Apple script. Okay, and then if we go down, create temp scpt file. Okay, so here we go. So we're just gonna change this to make it look prettier, I guess. I'm not sure if that looks prettier, but we have this that is returned mks temps. What is that? And this actually gets a bunch of stuff that did not show up here. I haven't seen what that was before. MKS temps. So let's see. Let me grab this and exit that, and then man, MKS temps. Okay. Make a temporary file name. Oh, okay. Cool. All right. So that makes sense, but it actually does get arguments, right? MKS temps. Yeah, there's 3 arguments. I wonder why it didn't, or 2 arguments. Didn't show up here. Oh no, we got to go back. Okay, so create temp here, and then here. Just change this. Add that. Oh, that's not going to work. So we're just going to int 32t r2, and then int 64t arg1. Oh, we can just name it template. It's not going to work. Okay, so arg1 for now. Okay, so we did get that we talked about already. So it's going to create that temp, that scpt temp file. So create temp, there, our file is there. Okay, cool. But there's something missing here. Why is it that, how does it get executed? Oh, here. And this has the wrong argument. So let's see where this is called. We have some strings here that tell you what happened to it. Okay, so let's see where this is called. So this happens down here. Write temp file failed. If it fails, it has some error messages. And then we have to find the do run script, which is called here. But we do have an argument that's passed to it, x20. So let's see, do run script. Arg, one argument, and we have run process, which I'm assuming gets this value. Bin sh is used here. Not sure why it's not showing up. So we're using bin sh to run this. And we're going to run process, and I am assuming this does some kind of popen, fork here. Okay, and then, so that's gonna execute this at some point. Dupe. Okay, here, and it executes it with sec v. So it runs, so this is how it's gonna actually run those scripts that are inside of that temporary directory that was called, so base 64 to string, whatever command was passed back, create that temp directory, which then gets put here, and then it ends up executing those scripts. And I think that was, so more Apple script, and I puts it into temp, ad hoc signed. I guess there's a code sign call somewhere. So let's find it. Code sign. Let's see. Oh yeah. Do action inject. Okay. Decode. So this is called from do work. It receives 2 arguments. These arguments came from before, and we generate a UUID. It decodes that. Not sure why it's just showing FP. It unlinks. So it deletes this temp thing. Does an F open. This string was not there. F open, and it does a chmod, and there's no arguments here. Chmod for these, display as sign decimal, and then it does that code sign, and then it passes this code sign argument to system. So we have a exec v, we have system call, and we have a popen call for different types of commands that want to get executed. Okay. And shell split, what's that? Maybe the return value gets split here. Mascaroon, I've never seen that before. Return something. So I think it probably, not sure. Not sure. Okay, that might be one to look at for fun. And it's actually called in 2 different functions. Okay, so I think we walked through most of what this does based on the code insights, because that's, all the rage now is using AI, and that's fine. It gathers extensive system metadata. We talked about that. Process list with that PS command. Transmits to the C2 server with some Windows stuff. Persistent loop. C2, we saw decoding. Yeah, so base 64 decode. Writes these SCPT files to the temp directory. Ad hoc signs, this separate though, to facilitate execution on modern macOS and execute arbitrary Apple script via OSA script. Okay, I think we covered the majority of it. There's not really much obfuscation here, or actually any obfuscation for some reason. And yeah, it's a pretty fun sample to go through. Again, I grabbed, or if you're interested, you can grab this from GitHub. What was it called again? WaveShaper. So of course, Objective-C samples, easy to get. And yeah, just looked at the ARM slice of the binary that's all over all the blogs right now. Okay, well, that's it. Hopefully that was interesting. Some fun manual slow reversing is always a good thing. Yeah, so it's been a while since I recorded something, but thought today would be good for this. All right, see y'all.